Okay, so let's start with the session. And the first thing which I want to tell you is this is an intermediate topic. This is some kind of a huge umbrella topic. So it's not a very narrow-sided topic, but if we go slowly and step by step, we'll be able to understand it much better. Right. So welcome to the talk. Let's now move forward. First of all, some details about me. You have been already introduced to what I do. So it's just a refresher on that. I'm a final year BTech undergraduate from IIT Bhubaneswar, and I'm pursuing electronics and communication engineering right now. And I primarily have interest in the computer science field, and so I've been working towards that right from my first year. And I'm actually a student ambassador, so it's a wonderful community where you get to share what you learn, and you get encouragement from people to actually host meetups and you know give talks like this one. So if you're a student and you're like sharing your knowledge with other people, do consider joining this community. I also have been a part of CNCF's Community Bridge program. It's now been renamed to LFX Mentee program, I guess. This is an open source program where similar to GSOC, where you just apply for any of the projects there and start working on open source project basically. So it's a really a wonderful opportunity. Again, if you are new to this, you should check it out, LFX mentorship, and it's really rewarding. Apart from that, I am a YouTuber and a blogger and tech speaker. So I love documenting whatever I work on. So I found that to be a very useful skill to have. So if you're looking for skills to develop this summer, this should be one of your top picks. So whatever you study, whatever you learn, you should make it a rule to always at least write some things about, document whatever you're doing, and tell the world about it, because that is how you can take real value out of your work as well. I love open source. That is something which is really crucial and really essential, fundamental to my beliefs. And you can find me on Twitter at WJS and pretty much everywhere else at WJS as well. So it's somewhat consistent across networks. Okay, that's enough introduction. What we'll cover today, the first thing that we're going to cover is how is development different from operations. Now, for many of you, both of these terms might be new. So what is development? What is operations? Right? And then we get to what is the difference between these two things. Correct. So we'll first cover what is development in very simple terms, what is operations, simple terms, and how they differ from each other. Then you might have heard of DevOps being spun around a lot in the internet and other places. So we'll understand what is the dev and what is the ops and how they come together in DevOps. Right. After that, we'll look at machine learning use cases. So DevOps is one stage, and then what happens if you add machine learning to it? Right. So this is a very emerging field, and we're excited to know how does the equation change when you put machine learning inside production use cases, and that will lead to the birth of MLOps. So MLOps is again a philosophy of how you deal with production, but we'll be covering all of that later on. After that, we'll be covering tools in the MLOps landscape. So basically, we'll be talking about what are the hot tools, how do you actually implement the MLOps philosophy. That's something which we'll cover there. Apart from that, finally, I'll talk about open source projects that you can contribute to. So this is something actionable. So after the event, you can feel motivated to go ahead and browse these projects first of all. Doesn't matter if you understand the code base entirely or not, but at least you'll have some motivation to check these projects out and see what they're up to, and see if you can contribute in any way possible. All right, so let's start with the first item on the agenda, which is development and operations. So development is just a part of a software machine learning lifecycle. So for people who are not really experienced with development, it's just writing out some software code. For example, if you have, say, for example, at school level or some other time, written any application, any simple application in Java, C++, whatever language of your choice, that is part of software which you write, right? You write some code, some logic which drives some kind of a need. For example, adding two integers together, or any other complex needs, right? So the basic thing is still the same. You write code, you have some logic which drives your software, right? And you maybe test your code, you add test. Maybe at this stage you're not familiar with testing that much, but going forward you'll always be adding tests to whatever you write, right? So this is the part of software development which is called development, basically software lifecycle. So this is just you writing on your own machine and not sending it anywhere, not giving it to other people to test out. That is local development, right? Now, what happens when you develop a software? For example, if you have developed something really great, for example, you have built a fancy new calculator for an Android application, right? So what you want to do next? You want to take this application and then somehow deploy it on some servers where people can access it, right? For example, the website of say has defined. So the folks have written those website, they've done the development right on their laptops, right? They have built this website, they have tested it on their local machine to see if it's working or not. And when it's finally working, what they do is they deploy it on some server, maybe on their own servers or some rented servers. And that is how everybody is able to access it. Is there a question? I think I saw somebody raise their hands. If there is, let me know. You can just unmute your mic. I think there is not. So yes, coming back to this place. So this is how these two things are divided. So I'll be talking about the operations part, but first let's understand development. Development is just local development, and then somehow you have to take this and make it available to everybody, basically. So the operations part deals with the second thing, where you take some code which is already built and tested. So you know this is working code. What you have to now do is find infrastructure to deploy it. And by infrastructure, I mean where should you deploy? For example, it's running on some laptop right now, but I want to take this to some server outside. And this server could be anything. It could be, say, a huge machine which is rented out by different corporations like Microsoft, Azure, or something of that sort, which is called the cloud. Or it can be some other set of machines, private cloud, and any of the other kinds of machines. So what the operations guys do is they find out where to apply all of this code, like to find the infrastructure first of all, and then to run this code in that infrastructure, basically. And then you have to maintain that code throughout the life cycle. So for example, you may think that throughout when running, there might be some hiccups in the implementation. For example, Instagram goes down sometimes here and there. Maybe WhatsApp stops functioning at some point. So all of that is also part of operations. So you have to make sure that for whatever code you have written doesn't fail. And if it fails, you might need to know why exactly it failed. And then you can give the feedback back to the development folks, and development folks will then release a fix for it. And then you have to take this fix and again apply it to all of your servers. Right? So this is how the two sides work, the development and the operations guys. So they are separate tasks, but they're somewhat interlinked to each other, right? So basically, to sum up, development is where you write code, test your code. Operations is where you maintain your code in production, you handle failures, and you monitor and log everything which is going on. Right? So is this part clear? Is everybody okay with what development is and what servers are and what operations is? If there's any doubt, let me know here, because this is really critical to understand. Okay, I think this is clear so far, which is nice. Then we move forward to these two diagrams. Now, this is something which you might have seen a lot on the top left. Is there a question? I think I heard somebody say something. It's all right. Okay. So I might imagine that you have seen this diagram on the top left a lot of times on the internet. So basically what happens here is this represents the DevOps flow, right? So how do you combine developer and operations together? You combine it using maybe this particular philosophy. So DevOps is just a way of enabling different teams to collaborate together, basically. So you have the developer team and you have the operations team, and you need to find a way so that both of these work together. So on the left, you can see there's a build phase. First of all, there's a code phase. So where you actually write the code. The development part starts writing the code. Then they build it. Building is just making an application out of your code. And then you test it continuously. And what does continuous testing mean? It means that you have some automated tests. So basically, you have written some tests down. And whenever you push your code to some repository, like you may be familiar with GitHub and Git. So just to add a refresher to it, it's basically how you track your code versions. So whenever you write some new code, you commit that code and you push it to some kind of a online storage, which is called a repository. Right? So this is how you write code, you build the code, and then you push it somewhere. Right? And then at that particular platform, there is some tests which are run, like which determine whether your code is right or not, whether it actually performs the tasks or not. And when the testings pass, then what you do is you release and deploy your software. Right? So all of this cycle, it keeps on going infinitely. So your testing happens, then release happens, then deployment happens. Deployment is taking your code to the servers. And then you have to operate, monitor, and then see if anything is wrong or not. If something is wrong, then you again plan, and then you again start coding. Right? So this is a kind of a loop which happens. And providing visibility on all stages to every developer is what DevOps essentially is about. So there are no silos, right? So you have constant communication between developers and operations guys. So you know, okay, your pipeline was deployed here, and these were the problems which happened on your pipeline. So you can always know how to amend or add a fix to it, basically. So this is what DevOps philosophy essentially means. right? So you need to have an idea of the entire flow. You can't just write some code and hand it over to some imaginary guys or the operations guys and let them handle everything else. So you'll have to keep an eye of the entire process basically. So this is what CI means. CI is continuous integration. What this means is whatever code you write is continuously integrated with your main code. For example, you have a base repository which holds all of your code. And now whenever you add something new, there are some tests which are run as is shown in the green bar. There are some tests which are run and then it continuously integrates, it merges with that existing repository. And then continuous deployment. What does this mean is that once the tests pass and once some criteria are met, it automatically releases that new version out to the public. So you may see this in say versions of Instagram where sometimes new features automatically pop up, right? So you haven't updated your application yet, but still you can see some new features that are available now. So this happens to this DevOps lifecycle. So essentially, what the Instagram developers do is they see, okay, this is a new feature which I can implement. They pass this test and they just quickly release that to the entire or maybe just a section of the users. So this is how this entire lifecycle works, the CI/CD pipeline. So this is really critical in DevOps, and this is also used extensively all around the place in MLOps, in any kind of automation which you may look at. These are really essential to it. We'll be looking at some pipelines later on, so you'll understand it better. But this is the fundamental idea. So there is continuous integration, there is continuous deployment. Sorry. So are there any doubts on CI/CD, because this is really essential? Okay, perfect. I think there are no doubts on CI/CD. And now continuous delivery is somewhat different to deployment. So in deployment, I said that the build is automatically deployed. So you don't have any way to stop it. So if the tests pass, the code automatically goes into production, right? So everybody can access it. But delivery just has an extra layer on top of it. So you have to manually press a button to actually deploy. So it's not really something which you need to worry about. It's just when you're talking about CI/CD, it's also important to mention about continuous delivery. Like just so if somebody asks you what exactly that is, but doesn't really matter in the grand scheme of things. Okay, so what does a DevOps engineer do? So that is something which is really critical, because you might be interested in DevOps, right? So after this discussion, you may be intrigued to find out what exactly DevOps is and how it works. And let me tell you, DevOps is really critical role. So because it actually orchestrates all communication between developers and operations, and a good DevOps engineer is really worth a lot to a company, right? So what exactly does a DevOps engineer do? So there are many critical tasks which are the responsibility of a DevOps engineer. The first thing is designing the infrastructure, right? So where exactly do you deploy all of your code, right? So where is the place where you actually take your code and run it? So that's the task of DevOps engineer. Then there's an automating processes, right? So basically, when you push your code to that repository, to the online repository, how are the tests automatically run, right? So this doesn't happen all magically, right? So there needs to be somebody who's writing the tests and configuring the environment in such a way that whenever you push your code to GitHub, some kind of tests run, right? So this is somewhat enabled by using GitHub Actions. That is one of the tools which a DevOps engineer can use. So DevOps engineer in itself doesn't write everything from scratch. They use a lot of DevOps tools which are available right now. So one of them is GitHub Actions. You can check that out. Whenever you go to GitHub repository, you can see the Actions tab there. You can learn more about what GitHub Actions are. These are really critical. And I think I also have a video on my channel on GitHub Actions, like how you can easily maybe push your code from VS Code and then have GitHub Actions run a workflow on top of that. So that is really simple. So you can check that out. That is like basic CI/CD stuff. All right. So this is the first thing. So a DevOps engineer should know where to deploy, how to automate processes, like how to make sure that whenever the code runs, some kind of workflow happens and then it are automatically integrated or deployed somewhere, right? That is a part of DevOps engineer job. Setting up monitoring and reporting, this is also very critical, because once the application is deployed, like once it is now running, we have to make sure that it's running correctly. It's not failing in between, or it's not running into some kind of issues. So you have to set up some kind of monitoring. So that, again, there are many tools for that. So Prometheus is one of the tools for cloud applications, where you can easily monitor how your application is doing. So what are the metrics? What is the response rate? What is the latency? Is it actually serving requests fast enough? So all of those things need to be captured and they need to be reported, because that is how you determine how your application is going to perform and if it needs some kind of improvement or not, right? So all of that is also part of a DevOps engineer's job. And finally, scripting, building, and figuring tools, making teams work better together. Essentially, you have the responsibility of making sure the development of the operations teams work together and they work nicely together. And you also have to write some scripts, which is part of the automating process again. So there's nothing much difference there, right? Now I'll show you maybe an example of what a DevOps pipeline looks like. So basically, it's similar to what we discussed before. So you have some kind of place where you write your code, then you push it. And this is the environment which you see here in this diagram is the environment where your tests are run, basically. So the QA is quality assurance. And so basically you push some code to this stage, and here you can have multiple jobs which run. So you can design, the DevOps engineer designs multiple tests. So like it designs how the test will be run in this stage, right? So basically this is the task of making sure that your new code is actually fit for production. And when these tests pass, it goes on to the next stage, which is production. And production is basically taking your code and applying it on whatever servers that you have. This is one example of a pipeline. The other example is the GitHub Actions, which I told you earlier. So this is really important. So again, essentially the same thing. You have you have 6 jobs in the first step, right? So you have maybe just set up, maybe installing libraries, and all of that happens in the first step. And in the second step, there are multiple tests here. You can see the first is the integration test. Second is the lint test. So lint is basically checking your code for linting issues. So all of these tests run next. And when all of these pass, we essentially know that our code is safe to be implemented, right? So that is how essentially pipelines look like. So this is how DevOps is, essentially in a very nutshell. Like I've covered just the surface of it. It's really interesting field. If you want to dive deeper, there are multiple resources available on this. But I hope I was able to make you somewhat clearer on what exactly DevOps does and what the DevOps engineer's roles are. So maybe I'll pause now and ask if anybody has any questions on DevOps, because in itself, it's a huge topic. But if you have any doubts, let me know right now.
हेलो भैया.
Yes, go ahead.
भैया ये पूछना था मेरे को कि DevOps के लिए बेस्ट प्लेटफॉर्म कौन सा होगा, मतलब अगर हमें लर्न करने सीखना है तो, और कहाँ से हमें स्टार्ट करना चाहिए?
Okay, DevOps के लिए बेस्ट प्लेटफॉर्म भी देखा जाए तो फॉर फ्री इट्स GitHub Actions, because like चालू करना है, if you want to start.
I'm sorry, आपकी वॉइस लैग हुई थी.
हेलो, क्या
आपकी वॉइस थोड़ी लैग हुई थी बीच में, फिर बोल सकते हैं
Okay, sorry about that. अभी audible है?
Yeah.
Is it still lagging? Hello?
No, आपकी आवाज से.
No, it's clear now.
Okay, it's clear. Okay, perfect. So what I'm saying is, for free, I think you should use GitHub Actions because it gives you a taste of how exactly automation works, right? So अगर तुम DevOps practice करनी तुम्हें, तो you should check out GitHub Actions. There are multiple, pre-configured actions. So you don't have to write an action yourself. तुम्हें समझना चाहिए पहले कि workflow क्या होता है. What is a workflow, right? And what is a trigger for a workflow? So essentially, triggers could be push, pull, ये सब चीजें. For example, in a GitHub repository, if you're going to push your code, that acts as a trigger for your workflow. और workflow कैसे होती है? Workflow, you define different steps. Like every workflow has multiple steps. जैसे इस workflow में 2 steps हैं. एक step पहला है कि it installs, it sets up whatever applications are required, whatever libraries are required for my code. And the second step, it runs multiple tests. Right? That is the idea. So if you want to try DevOps and see how it works, GitHub Actions is one easy way. Otherwise, अगर तुम्हारे पास, like if you have an Azure subscription या किसी cloud provider का subscription है, then you can check out say Azure DevOps. So basically वो चीजें same ही हैं. ठीक है, मतलब इतना कोई difference है नहीं. GitHub Actions क्या होता है कि GitHub provides you with their own machines to run the tests on, because ये जो tests run कर रहे हैं GitHub की खुद की machines पर run होता है, and they don't charge you for that for open source projects as such. But if you use Azure DevOps, basically you have to pay for the machines, क्योंकि टेस्ट कहीं तो रन होंगे. It's not running on your own machine, it's running on some other machine. So basically उसका रेंट लेते हैं वो. So if you want to just test out right now and see, maybe develop some kind of CI/CD flow, I think GitHub Actions is the place to be. Any other questions? So Rams, like it's an important topic. So even if you have any slight doubt, let me know. Like this is where we transition to MLOps at this stage. Okay, I think there aren't any questions. So maybe I'll move forward. So adding ML to the mix. Like so far, we only talked about like basic application code. हमने Java में कोई code लिख दिया, and then you try to take it in a pipeline and then deploy it somewhere. Right? So this is a very linear, straightforward process. But what happens if you add ML to the mix? Right? So first of all, let me start with a few statistics. Like we know machine learning is hard. Like machine learning in itself is a hard practice because you have to do some kind of experimentation. You have to find out. You have to be engaged in a lot of data processing, a lot of hyperparameter functions. So all of that is really hard. But deploying to production is even harder. because once you have developed your entire model locally on your machine, the story doesn't end there. What you have to do is essentially take your model and then take it to some new environment, entirely new environment. Because right now what happened was you supplied the data, you had a familiar environment to test your model, but taking it to production, you never know how it's going to turn out. So just to give you some idea of how hard this is, there was a study which was conducted by Algorithmia in 2020, and it found that the majority of companies spend around 8 to 90 days deploying a single machine learning model. And if that's not surprising enough, almost 90% of the models never make it to production. Right? So you have your data scientists working hard on some kind of model, but if your production side is not strong enough, if the MLOps team is not strong enough, the model will never make it to production. Right? So this is really challenging, and a lot of firms are trying to solve this problem. Right? So to further bring out how it is different from DevOps, let us start to look at some kind of diagrams here. So yeah, is there a question? Okay, not. So we know how the DevOps look like for now. We have this code, we have automated tests, and then we have deployment and maintenance. So here flow, we looked at this flow some time back, right? So we have some idea of how this happens. So this code is there on the left. Then it is sent to some kind of GitHub repository. There are some tests which are running, and then if the tests are accepted, we deploy that, and then we maintain it. We basically monitor all kinds of logs for it. So this is simple. It's kind of a linear flow, right? There are no twists and turns in this. For example, तुम्हें कुछ भी modify करना है, if you have to change something else, you just modify the code here, push it again, and then test run deployment happens. It's pretty straightforward as a flow. Correct? And now what happens with MLOps? How is it different with MLOps? So let's start with the first fundamental change. Now you have a data which comes in. So you don't not only have code which needs to be tested and modified, you also have data. Because in ML, what happens is data drives decisions a lot. So tomorrow code could be very fine, like it could be the best code which you have written, but if the data changes, all of your machine learning changes essentially. So data is crucial and it's at the center of machine learning, right? So this is the first fundamental difference between MLOps and DevOps basically. So you have data which you need to version and experiment track. And why do you need to version data? Because ultimately, let's just say you have trained your model with some kind of data, say X data, this version 1 data you have trained it with. Now in the future, you might have some kind of new data which comes in, like some new research gave you some new data, and you know that this data is going to better your model performance. So what you're going to do is you take that new version and then again train your model, right? So how do you track what data you're training your model with? So it becomes essential that you have some kind of versioning system. कि मुझे पता हो कि this is the first version of the data which I train a model on. This is the second version, and I also need to track each of the experiments which I do, right? So this is the basic need of an ML workflow. So what we're going to discuss now is separate needs of each stage of the ML workflow. So we're going to discuss what an ML flow workflow looks like, and then we're going to talk about how exactly MLOps can solve all of that. So what you can see in the black section here, in the black pen, is model development. So whatever you know about machine learning is only a part of that. So that's all that is to model development. So algorithm selection, architecture selection, hyperparameter tuning, all of that happens within that box there. Right, so that is the model. You have iterative model training. You have some data which is version, which is tracked, and then you supply this data to the model. Right, and that is the start. That is essentially the part of machine learning which you already know about and which you may have guessed out, right? And now again, in this section as well, in the training section as well, there might be some parameters which give you very good results. Like there might be some values for different hyperparameters which are giving you really good performance. But at some cases, there might be not good values as well. But both of these cases are important. You have to store and track each and different experiment. Correct? Because for example, let's just say I ran my model 20 times. Right? And for example, I remember that at some stage I got really nice performance, but I don't remember exactly when that happened. And that often happens when you do it locally. Right? You have your own Jupyter notebook. For example, you are sitting at your home and trying out some kind of a Kaggle notebook or some kind of any machine learning problem, basically. Right? And you start out, you just keep experimenting, tum change karte the values, you don't have any idea of what exactly you're changing. There is no tracked history of it when you're doing it in a notebook, right? So you have different kinds of stuff which is going on, and then essentially what happens is you forget at what set of combinations you had the best values, right? So you run multiple trainings, and that gets lost in the entire experimentation. So what we need from an MLOps platform or from an MLOps framework is that there needs to be some way of tracking every run. So every time you run your model, there needs to be some kind of automatic tracking system which has this feature of essentially locking down, okay, these were for this run you had these parameters and gave these many results essentially. So this is also one of the needs. So we discussed two needs so far. The first need of a platform or a framework should be you have version data, right? So you can track what version of data you're using to train your model. And the second thing is you should also be able to track what parameters you're going to use for your model. So how did you design your model, and what is the result that the model gave you? Right? So this is the first need. And this is somewhat largely different from how we handle software life cycles, right? So in software, you just write code, test it, it works fine, and then goes to the next stage. But here you have to iteratively keep on working on it. You have to experiment a lot. So ML is all about experimentation. So even in the first stage, there is huge experimentation, there is huge tracking which needs to go on. And whenever the data changes, again, you have to start training a model. So it adds a lot of complexity on top of that. So you can't just have a very simple GitHub push to keep it working. You need to have some way to inject data into it and then monitor the entire process. So it's not as simple as a DevOps pipeline, right? So this is the first step which happens, right? What happens in the second step is automated validations, right? It's similar to automated tests. So you saw in the DevOps pipeline, what happened is when you pushed your code, it went into this GitHub Actions scene, and then some kind of tests ran automatically. So you had maybe some unit tests which were there to verify if your logic is correct or not, right? In the case of machine learning, testing the code in itself is not sufficient, as I already told you. Your code might be correct. Your code might be logically correct. Okay, this is how it is. This is the architecture which I'm going to use, and it is syntactically and logically correct. But what can change is the data, right? So you need to make sure you're supplying the correct data to it. So whenever your testing environment, so testing environment can be different. For example, in the GitHub Actions case, the testing environment is the GitHub's machines. It's not running on your own local machine, right? So that is something which you need to take care of. For example, when you're developing your model locally, tumne use the local data for your own machine. For example, you maybe downloaded some data from some kind of online data set, and then you use that to train your local model. But when you're actually pushing it to GitHub now, GitHub environment needs to have the same set of data. For example, if you have some kind of distribution change, again, there will be some problems in the tests. So you need to make sure that this data is as consistent with the data which you supply to the testing environment and any other environments in the future, basically. That is also one of the needs of any kind of framework which you want to use, that it needs to have some mechanism in which the data consistency can be maintained. And you also need to ensure right pre-processing, because every time data comes into any machine learning model, it is first pre-processed in some way, because you apply some, say, normalization. There are multiple other things that people do to the data before supplying it to any model, right? So when you're testing that model, again, what needs to happen is you need to apply the same pre-processing. Essentially, you have some other kind of stuff going on there, because it will again affect your model performance. So what this MLOps needs to do is it needs to supply the same data or the correct data and the same set of pre-processing knowledge to any automated environment or any other environment where your model is going to run on. Right, so that is again one of the critical requirements for any MLOps platform. Right, so far, is it clear? So far, do we understand where the complexity is coming in as compared to DevOps? Okay. So if you feel overwhelmed at any stage, if you feel it's too much, let me know. I will stop. I'll maybe go over it again, right? Because by default, MLOps is obviously more complex than DevOps, right? And DevOps in itself is a very hard to understand. Let me know at any stage. All right. So far, just to summarize what we discussed, are the first two stages in MLOps pipeline. So the first stage is the experimentation phase, where you experiment with your model, you do all sorts of testing, you add new parameters, and we want that MLOps should track all of these changes which I do. You should also track what data I'm using, what is the version of the data, and how good the data is. All of that should be tracked. The second thing is whenever I send my model to some kind of testing environment, it should make sure, the MLOps should make sure that I have the same data and same pre-processing there, so that my model performance can be actually tested very well. All right, so the third part is deployment. Right, so for example, you were successful in actually sending the right data and the test passed. Okay, so now you're confident that my model is working fine and it is ready for deployment. So it is ready for facing the consumer world. Okay, so when that is happening, you actually deploy your model. You take your model and then you serve it on some online website. Essentially, that is how you can access any kind of machine learning model. You might be familiar with Hugging Face or some other kinds of services which are available online, where you can essentially use machine learning models in production. Are you familiar with computer vision? Anybody here knows anything about computer vision and those APIs? So essentially, like any websites which are there for fun, where you can just upload your picture and they do some kind of modification there. Right. So all of these are essentially machine learning models in production. So what they have is on their website they have deployed some kind of machine learning model which they have developed. And what you do is you just supply a data to it. You supply some input, and they use the model to supply some prediction back to you. Right. So there are multiple websites there. You can try that for fun. Right. So even you have some GAN generators. You can just write something that I need a picture of, say, a squirrel. And then the machine learning model will then read this sentence and then generate an image of a squirrel. So all of this is available as websites, as deployed services. So how does that happen? That happens through the deployment phase. So only when the people know that, okay, their model is working fine, they deploy it on some kind of an environment. Right? So that is the stage is called deployment. And even in deployment, there are multiple challenges. So the first challenge is data drift and model drift. Essentially, what I'm trying to say is this. So maybe when you're training your data, for example, let's just take the example of demographics. So let's just say I had trained my model on some kind of a set of people which I had available to me. So I had data from 10,000 people available to me, and I trained a model on that. It worked very perfectly and deployed it to the cloud. Now what might happen is my service can get popular, and there may be hundreds of other people which are going to use my service. Let's just say not from this set of people, but some other set of people as well, which have started to use it, like which have some kind of different characteristics to these people. Right. So what will happen now is my model will not be able to react to it very well, because my model was trained on this set of data, and now there's new data which is coming in. So that is a flaw in deployment. Now my model is not failed yet, right? So it's not traditional failure. It's still running there, it's still returning results. So you can't classify it as some kind of a traditional failure, but it is returning the wrong results. So that is when you say that the model is actually wrong and it is at fault. So there needs to be some way of MLOps to determine that the data which is coming in for inference is different from what you trained on. That is also one of the very strong needs in MLOps, right? So for example, whatever framework you're going to use to implement MLOps, there needs to be some mechanism again which tests out, okay, this is data which is coming in, this is the data you trained your model on, these are different. So what you need to do is you need to retrain your model essentially, right? So that is the next step. So it happens all again and again. So with the DevOps pipeline, you had a very linear flow, right? So you had this linear flow, but here what you have is there needs to be multiple stages that go on. So in any case, if you see, there is no failure here, right? There is no failure, there is nothing wrong going on, but the model itself is not getting the right results. So in that scenario, what you'll do is again, maybe send your model back into training stage, essentially. So all of this needs to be handled by an MLOps framework, right? So you don't implement that yourself. That is not your job. So this is really hectic to write all of it on your own. So there are multiple tools for which we're going to discuss later on. But essentially, these are the requirements which I'm trying to discuss. And I'm trying to make sure you understand how complex this is and what are the different challenges at every stage of a pipeline. Right? So deployment is covered. So in deployment, you have to make sure there is no data drift. By data drift, I mean there is no change in the distribution of the data which comes in for inference and the data which is there for training. Right? Then they needs to be from the same distribution. That is a part of making sure deployment is going perfectly. The next part is maintenance and monitoring. Again, it's the same thing. So once it is in deployment, you have to keep monitoring and keep maintaining your model. You have to see if the prediction is coming right, if there is no data drift, and if your AI is responsibly giving back results. Right? That is the idea behind it. Right. So just to reiterate, just to summarize, what is present in the black pen there on the left, that is the only part where you're actually developing your model. Right? And then there is this whole entire section where there is no model deployment at all. So the places, the blue, the green, and the pink part, and even the violet part, some part of the violet part is not a part of model development at all. So that is all taking your model and then making sure your model is running perfectly in the production environment. And this is the job of an MLOps person. So the MLOps guy the MLOps person needs to actually figure out a way to use the right tools to design such a pipeline which has all of these characteristics. So if you are an MLOps engineer, what you need to do is you need to find out, okay, these are the tools I'm going to use. This is the pipeline I'm going to define. And this pipeline will satisfy all these characteristics. So it will have, say, a place to detect data drift. It will have a place to supply correct data. So all of this needs to be part of the job of an MLOps engineer. right? So the black part is the part of data scientists. So those are the guys who develop the model itself. So you don't have to worry about what architecture they're going to use or like what are the hyperparameters that they're using. So all of that knowledge resides with the data scientists. Those are the guys which are actually fluent in machine learning and develop it. But it doesn't stop there, as you can see. So the MLOps engineer needs to handle a lot more things and a large part of maintaining the model as a part of it. And that is why MLOps is such an emerging field. And because ultimately the model on the left has no value if the blue, green, and pink parts are not there. Because you may have a very high functioning model, but it's of no use if it's not in production, if it's not going to be used by a lot of people. And that is essentially the value which MLOps provides. So it gives you this huge potential to actually leverage any kind of models that you have. Right. So this is MLOps in a nutshell. Now, just to compare it again with software development life cycles, I think so far we are clear on what exactly MLOps is. If there is any question, I'll be happy to take them right now on any of this diagram. So if you have problems with any of these stages, you can just unmute yourself and ask, or you just write a comment, any of these things. Actually, I'm unable to read the comments. So if you're putting it there, I'm not able to see it. So maybe one of the mods can help me with that. But that is it. Okay, I think there are no questions on this, which is nice. I hope you understood some part of how it is different from DevOps, what are the added challenges, and what are the different stages in MLOps. Okay, now let's just, again, go through it again, maybe some kind of a summary, and compare how it is different from usual development cycles. Right, so as you see, the most obvious difference is the iterative property of it. So the model exploration, model refinement is a continuous process in itself. Right? So the coding part itself is really hectic. So you have to keep tracking everything. You have to make sure the model is working perfectly. And again, whenever new data comes in, you have to make sure that you retrain your model so that it's giving the right results. But that is also different from a traditional software lifecycle. And again, as I told you, machine learning can fail without the usual indications of failure. So your service might be running very perfectly. It might be returning results in a very fast manner. The latency might be very less, but the results which come back might not be right. Okay, so the machine learning models can fail silently. So you might not even know that your machine learning model has failed. So you need to have additional checks. So you don't have to just monitor, you don't have to just maintain your model, you also have to monitor what the results of the model are. Right? So that is an additional step on top of just pure maintenance. Right? And it should be possible to alter your model parameters as frequently as possible. So all of these are additional responsibilities on top of software life cycles, which machine learning models have. Right. So this is essentially the primary challenges with machine learning. And again, there's a human side to the problem, right? Because what we have seen is data scientists don't understand DevOps. Right? Data scientists are only worried about like getting the model to work. Right? How exactly does the model function? All that is part of the data scientist job. But they don't understand DevOps. They don't understand how the pipelines work or how the tests work. And the DevOps guys don't understand how data science works. Right? So all of this also adds to the challenge of people. So the friction between that really makes it really hard to have some kind of changes being deployed. Right? So the MLOps framework which you use or the MLOps which you use needs to have a way in which it facilitates communication and facilitates transparency between these two sides essentially. Right? So basically you need to have a platform which will allow people to able to see and observe each part of the process. So the data scientist knows, okay, this is the place where my model is running and this is how it performs essentially. Right? So that is where the MLOps comes in finally. Right? So I think so far we have understood what is the motivation behind MLOps, like why MLOps is exactly required. And this is MLOps in itself. So it's an intersection between DevOps, machine learning, and data engineering, as we already talked about. So the DevOps part is the CI/CD part where you have these pipelines which run. The machine learning part is where you do the experimentation. You supply some parameters, you just find out these things. All of this part of the machine learning. And then your data engineering part, which deals with how data is dealt with. How do you preprocess your data? How do you version your data? All of that is covered in MLOps essentially. So it's a huge field which takes care of all of these things. So essentially the goals are fast experimentation. So what you need to do is you need to provide a platform where people can experiment really fast and with tracked artifacts. There needs to be fast deployment. So whenever you're ready with a model and quality assurance, there needs to be some kind of monitoring which goes on, some kind of quality assurance that makes sure your model is running very perfectly. And then there needs to be easy handoff between data scientists and engineers. So there should be some kind of good communication. There needs to be some way in which people are really aware of what's going on. That is what MLOps should do, right? Essentially. So now, once you understood what MLOps is, let's look at some tools which I have finally enable you to do all of these things, right? So we have talked a lot about the different stages, what the challenges are and all that stuff. But how exactly do you solve these things, right? So what is the solution for it? What tools am I going to use as an MLOps engineer? For example, if I'm an MLOps engineer, what do I look at? How do I design my solution in such a way that I can take a model and take it to production, essentially? So there are two kinds of tools which are available to you. The first is the platforms. So essentially what a platform is that it provides you software plus hardware. For example, in Azure Machine Learning, you can just go on the portal for Azure Machine Learning Studio, and then you can just start an experiment right away. So Azure gives you the hardware where your machining model runs, essentially. So you don't have to run it on your own system. You can run it on Azure's machines, and you get charged for that. You have to pay some kind of rent for using those machines, right? So Azure Machine Learning is a platform because it gives you the hardware and it gives you the software. It gives you the software in the sense it gives you a UI or a GUI where you can easily write your own code, click on buttons to deploy, to test all of that. So it also gives you a software, it also gives you hardware. So that is what a platform essentially means, basically. And frameworks, on the other hand, are stuff which don't have any hardware to it. So essentially using ZenML is one of the frameworks for enabling MLOps. So what ZenML does, it doesn't care about where you're going to run your model. If you can run a local machine, you can run Azure Machine Learning on SageMaker on Google Cloud AI platform. So the backend could be anything, essentially. So it doesn't matter what your hardware is. ZenML will give you a framework to write software, write your own code, and deploy it essentially everywhere. And this is the difference between platforms and frameworks. So what we're going to do now is going to look at some example for ZenML. And we're going to understand how exactly ZenML enables you to accomplish all of the tasks, all of the challenges which we saw earlier, right? So now this is essentially what a pipeline in ZenML looks like, right? So don't get intimidated by the words and all of the stuff there. I'll be going through very slowly through each of them. So essentially, these are the parts where you can easily relate to machine learning. So importer is a step which might take data from some external source and put it in your model, right? So essentially this is a pipeline in ZenML. So using ZenML, you can define pipelines in Python. So for people who are familiar with Python, this will be very simple to understand. So essentially you define a pipeline. We'll be looking at the code really soon, so don't worry about that. Everything will be clear when we look at the code in just a minute. But this is essentially how it happens. So you have this is separate environment from code. You have this entire pipeline. You have these steps which are followed in a sequential manner, right? So you have an importer, then you have an analyzer, then you have a trainer which trains your model, then something which validates your model, and when you're finally satisfied, you can deploy your model. And again, it can go back, right? You can run this pipeline multiple times because ultimately you have to track how your pipeline performed in every step, right? So all of this is part of this ZenML pipelines. Now, to understand it much better, let's actually look at some demos. So I'll be sharing with you. Just give me a second. Okay. So I'll be showing you a repository which we have, and it's kind of an MLOps course which you can follow, basically. Right. So this is the ZenBytes repository. Is the zoom enough, or should I zoom in a bit more? Is the screen visible?
Yes, it is visible.
Okay, sure. Thank you. All right. So essentially, let's just take a look at one of the pipelines from ZenML. Right. So this is the ZenBytes repository. Is a repository where you can find a lot of tutorials here. So it starts with the first, which is the basics. So it basically explains to you what ZenML is, how you can define different steps, what a pipeline is, all of that stuff, right? And this is the part where we actually define a training pipeline. So I'll be taking a look at this one with you, and we'll go step by step, understand everything. You can just ignore the part which I'm skipping here. Right? So this is the pipeline. This is the first pipeline that you need to understand. Right? So you have an importer, you have a trainer, and you have an evaluator. Right? So this looks like a very typical machine learning flow. Right? So whenever you're trying to build any machine learning model, you're going to have these steps essentially. So when you're developing in some kind of a notebook, you don't explicitly mention these steps. You still have them in your mind. Okay, this is the first part that I need to do. You have to import some kind of data. Then I have to train a model on top of that data. And then I have to evaluate if my data is right or not. So with ZenML, what you do is by default, you start with different steps. So while writing your code in Python, you actually define different steps explicitly, right? So what I'm trying to mention is this. So if you look at this pipeline here, so define a pipeline using the Python decorator, which is add pipeline. Right? This is provided by ZenML library. So what you do is you define a function here. It's a simple function, right? So define digits pipeline. So that is a part of a function. You label it with a pipeline tag, and basically it then defines what are different steps inside this pipeline. So the first step is the importer step. The second step is the trainer step. The third is the evaluator step, as you looked in the diagram above. So we have defined a pipeline with these three functions. And here we're going to link these steps together, essentially. So whatever importer function you use, it should return your training data, your test data, all of that should be here, right? This is essentially how we define an importer step. And then these data should be passed on to a trainer step, right? So the trainer step will return you a model. And essentially the evaluator step will take this data and the model to test your model, essentially. So on a high level, this is how you define a pipeline in ZenML, right? It's just plain simple. It's just using Python. It's nothing extraordinary. You just have to supply a add pipeline tag to it, and then you can keep on linking the steps together, essentially, right? So the first pipeline, and now here you are initializing the pipeline actually. So you have defined the pipeline here, and you initialize the pipeline with three different functions. So you're supplying an importer function, a trainer function, an evaluator function. Now, what exactly are these functions, right? So for that, we'll scroll slightly up and see here. So this is again a simple Python function. So you have dev define importer function, and it returns an output where you have all of these variables available to you. So you define an add step decorator, which tells ZenML that, okay, this is a step in a part of a pipeline, essentially. So you can implement any logic here. So it doesn't have to be this logic. You can maybe just call an API. You can even download from, say, Google Drive or some other place, right? So you can define any logic here, which actually gets your data from some place and you return that data, essentially. So this is the first step. In the trainer step, here is where you actually define your models. So all of your machine learning code will go inside this place, right? So essentially you have this SVC model, which you're going to use here. And you can have any other model which you define. So you can have all sorts of architectures, hyperparameters, all of that logic goes inside this trainer step. So it looks like a very simple step in this particular case, but you can have any complex logic built into it. So it doesn't really matter in that sense. So we're just trying to, on a very high level, understand what the different steps in a machine learning engineering pipeline looks like. So this is the trainer step. It takes in the train input and output. So train input and test output. And then you look at how you can actually train this model with some hyperparameter. Let's say you supply some gamma value, just you fit the model to it, essentially. And then you return this model, basically. Then comes the evaluator step. Again, you take the model, you take the test inputs and test outputs, and then you basically try to see what the accuracy for the model is. This is the evaluator step. So this is how a pipeline looks like, essentially, in ZenML. So you define a pipeline, you just run a pipeline this way. You just do first pipeline.run, and it starts running a pipeline, basically. Right. So this is the idea behind what exactly a ZenML pipeline looks like. This is how it runs, basically. And now where it runs, you don't know where exactly it is running, how data is being transferred to all of it. It's taken care of by ZenML, and you define different stacks for it. You have the option to tell ZenML, okay, this is the environment which I want to run my example, and ZenML takes care of actually taking your code here and then taking it to the testing environment. All of that stuff can happen with the help of ZenML. So basically, you don't have to worry about any of that. Right, so this is a very simple pipeline here. I won't be going into details here. There's a lot of other things that you can check out later on, but don't worry about any of that, essentially. Right. So this is something which is, I just wanted to give you an idea of how exactly things are implemented. Right. So this is something which is somewhat complex at this stage, but I'm happy that at least I was able to touch on how exactly things look like in actual real life production. So any company which is trying to build their own applications, they use tools like ZenML to actually define these different steps and then run these steps on any kind of stacks, right? So the code which you saw earlier didn't have any mention of where the code was running. It didn't mention Azure, didn't mention AWS or any kinds of local things. So that is configured separately in stacks. So you can define a local stack so that you can run your machine learning code locally. You can define a Kubeflow stack which runs on the cloud and all sorts of stuff like that, basically. So it's maybe decoupling all of these things together so that it gives you a lot of flexibility, essentially. Okay, so going back to the presentation, so it's a lot of stuff to cover. These are some open source projects that you can actually contribute to, right? So this is really important. So you can look at, say, ZenML, which I just showed you, which is an entire framework which allows you to build all kinds of pipelines right from the start. Then there are things like MLflow, which is also one of the very cool projects here. There's evidently.ai, which helps you detect data drift. So we already talked about what data drift is. Is the difference between, is a change in distribution for data which comes in for inference and data which comes in from training. Right. So evidently is an open source tool which helps you actually figure out if there's some change or not. Right. So as an MLOps engineer, you don't have to worry about any of this stuff yourself, essentially. So there are a lot of challenges which you talked about, but using these tools, you can easily solve those things very fast. So you don't have to worry about actually implementing from scratch all of the logic which determines data drift or which determines pipelines and all that stuff. Right? So it makes your life easier a bit. So I'll encourage you to check out these tools. If you don't understand, check out documentation for it. If you reach out to me if you have any doubts for any of these projects, but you should make sure that you have some idea of what these things are. Maybe try their examples. Like each of these repositories have their own examples. They have their own quick starts. So you can just maybe run a simple pipeline yourself and see how it works. Right? So you don't have to have any high-tech machines for that. You can rent on your own local machine. So just take ZenML, go to the ZenML's GitHub page, find out an example, start running on a local machine. So that way you'll be able to see exactly how models like that function. For example, the pipeline which we saw earlier right now, it's also a very simple pipeline. It just takes some input, trains a model on it, and just does an evaluation. And it all happens in the context of a pipeline, which I can run multiple times, right? Because I defined a pipeline and I initialized a pipeline. Now this pipeline can be run multiple times, and all of these runs are tracked, and I'll be able to see exactly how each of these things happen, basically. So there's no time to actually show you these things up and running, and it'll take some time on my machine as well to run. But I encourage you to actually check those out. If you have any trouble, if you see any errors or don't understand stuff, you can always reach out to me. I'll be happy to get on a call or get on some other session to actually show you how pipelines like that work. And like this is essentially the end of my presentation. And now we'll be opening the floor for any questions or any other kinds of doubts if you have. I know it's been a somewhat of a complex talk in itself, but the purpose would be to essentially allow you to understand like this is a new field, this is a really emerging field, and there are lots of companies who require MLOps engineers because essentially machine learning is now a part of every company's workflow. So everybody's looking to machine learning to actually improve their user experiences, and there needs to be some MLOps teams which actually take your model to production, right? And these are some of the tools which I shared. The team might also be sharing this presentation with you at some point, so you can also take a look at all the links which I had in the presentation. So don't worry about that. And essentially, if you start exploring these tools at this early stage of your college life, then you might have some advantage going forward in MLOps field, because this field is going to explode in the coming years, and the need for good MLOps engineers will always going to be there. So these tools might act as a head start for you to actually dive into the world of MLOps. So this is essentially it. It's a very starter kind of session. So we didn't dive deeper into many of the concepts, but I think I was able to scratch the surface well enough.